If you tear your ACL playing a sport, chances are nobody even touched you. Up to 70% of all ACL injuries occur without any physical contact from another player. As the athlete is suspended in the air, the mechanical risk is concentrated in the milliseconds right before their feet strike the floor. In this video, we are going to rebuild your jump mechanics from the ground up by teaching you how to execute a soft landing. This is a specific biomechanical correction. Applying the soft landing technique is shown to reduce the total impact forces traveling through your knees by up to 25%. Mastering this movement pattern shifts the workload away from vulnerable ligaments, helping you maintain a more stable and resilient knee joint. Step 1 is checking your current mechanics. Stand up, perform a basic hop in place, and listen to the sound your feet make when you hit the ground. If your landing sounds heavy, you are likely performing a stiff landing. This occurs when you hit the ground fully upright, with almost no bend in your knees or your hips. When you land straight-legged, you lose your body's natural shock absorption. Every ounce of kinetic energy sends a jarring shudder through your skeletal system. Data shows that landing this way on a single leg increases the peak forces applied directly to your ACL by 23%. To fix this, you must lead with a hip hinge. As your feet make contact with the floor, push your hips backward as if you were sitting into a chair. On the left, the proper technique shows the hips back and torso forward. On the right, the athlete stays vertical and only bends their knees. This creates anterior shear, a sliding pressure driving the thigh bone forward against the shin. To keep the knee functioning correctly as a true hinge, your hips must act as the primary shock absorption system during every landing. To practice this, find a sturdy box or step 6 to 12 inches high. This low-altitude drop allows you to rehearse the mechanics in a controlled environment. Avoid the common mistake of internal focus, where you try to micromanage every joint angle. This usually leads to robotic and stiff movements. Instead, use an external focus cue. Step off the box and focus exclusively on landing as softly and quietly as possible. This chart displays the vertical ground reaction force during landing. It shows how mental cues change physical mechanics. The blue dashed line, the soft condition, drastically reduces peak impact force and shows significantly higher knee flexion angles. Simply setting the mental goal to be quiet forces your neuromuscular system to automatically recruit the correct shock absorption mechanics. For step 3, you need to check your alignment. Perform the box drop again facing a mirror or a smartphone camera so you can see your knees from the front. You are looking for a specific flaw where the knee joint aggressively buckles inward toward the center line of your body upon impact. This inward caving is known as dynamic knee valgus. It is a major risk factor for catastrophic non-contact ACL tears. To correct this, keep your hip bones level and force your kneecap to track directly over your second toe. Now advance the training to the single leg deceleration drill. Jump forward off of one leg and land exclusively on the other. Sink deep into that hip hinge upon impact. Freeze the position and hold it perfectly stable for 3 seconds. Mastering this asymmetric weight distribution ensures your body can handle the unpredictable one-legged forces encountered in a real game. Practicing these controlled drops and deceleration hops rewires your body's subconscious default landing patterns over time. A safe jump requires merging deep hip engagement with strict knee-over-toe alignment and a quiet auditory focus. Integrate these drills into your pre-game or pre-workout warm-up routine to prime your nervous system for safe movement before you play. Removing stiff landings from your movement vocabulary prevents the extreme spikes in force that lead to ACL failure, allowing you to remain effective and healthy on the court.